Theorem: state and prove the mean value theorem for a harmonic functions statement. Let U be a harmonic in a region R. Also, let Pxyz be given point in R and SPR be a sphere with a center at P such that SPR is a completely contained in the domain of a harmonicity of U, then UP equals to U bar R equals to 1 upon 4 pi R square surface integral SPR U Q ds, where Q equals to xi, eta, zeta is any variable of the point on the surface of a sphere SPR and ds is the surface element of a integration. Proof: since U is a harmonic in R and also we know that its spherical mean U bar R is a continuous in R, which is given by U bar R equals to 1 upon 4 pi R squared surface integral SPR U Q ds equals to 1 upon 4 pi R squared integral 0 to 2 pi integral 0 to pi U xi eta zeta R square sin theta d phi, which implies du bar R upon dr equals to 1 upon 4 pi integral 0 to 2 pi integral 0 to pi U xi R plus U eta R plus U zeta R into sin theta d theta d phi. Equation 1. In the spherical polar coordinates we have xi equals to x plus r sin theta cos phi, eta equals to y plus r sin theta sin phi, and zeta equals to z plus r cos of theta. So we have xi r equals to sin theta cos phi, eta r equals to sin theta sin phi, zeta r equals to cos of theta. Putting these values in A, we get du bar r upon dr equals to 1 upon 4 pi integral 0 to 2 pi integral 0 to pi u xi sin theta cos phi plus u eta sin theta sin phi plus u zeta cos theta into sin theta d phi. Equation 2. Since sin theta cos phi, sin theta sin phi and cos of theta are the direction cosines of a normal n cap on SPR, therefore del u equals to I u eta plus j u I u xi plus j u eta plus k u zeta and n cap equals to I n1 j n2 k n3. Thus the expression within the brackets on the right hand side of equation 2 can be written as del u dot n cap. Therefore equation 2 becomes du bar r upon dr equals to 1 upon 4 pi r square integral surface integral SPR del u dot n cap r square sin theta d phi equals to 1 upon 4 pi r square surface integral SPR del u n cap dot n cap ds equals to 1 upon 4 pi r square volume integral PR del dot du dv by the divergence theorem equals to 1 upon 4 pi r square volume integral VPR del square U dV equals to 0, as U is a harmonic, so del square U equals to 0. Therefore, du bar over dr equals to 0, which implies U bar is a constant. Now U is a continuous at r equals to 0, which implies limit r tend to 0 U bar r equals to UP. Therefore, we have U bar r equals to UP equals to 1 upon 4 pi r square surface integral SPR UQ ds.